Hello, this is Puya. I'm just going to continue on PID control. I'm just going to talk about how to implement PID control analogously using op-amp. Using op-amp is an analog device, so we want to see how we can use op-amp to implement PID. So before we start talking about PID control, I want to remind you about the operation of an op-amp. So as you know, op-amp has two input pins, non-inverting and inverting, and it has an output, so like let's call this one VP and VN, and this one is VO output. It also has two power supply pins, VCC plus and VCC minus. So the way op-amp is usually modeled is using a very large input resistance, and there is a dependent voltage source which its value is A times VP minus VN, and it has a very small output resistance, let's call it RO. So ideally we assume Rn is a very large number, R out is very small number, and the open loop gain called A is also a very huge number. So because this resistance, input resistance, is very small, we can assume that the input current that goes through resistor is very small. So IN, for both of them, IN, let's call this IN positive, IN, I sub N negative, both of them are close to zero. Now, so, well, like there's no infinite resistance, there's no infinite gain. These are like just very huge numbers, and the op-amp tries to keep these two voltages the same. So in most of our studies, we have VP almost equal VN. So you can see here VO is equal to A times VP minus VN. This is a very huge number, this is a very small number. So like in mathematically, this is not defined, right? It can be any number. It's not zero, it's not infinity, so VO can be any number. If op-amp is not saturated, it can keep VP and VN to be not exactly, almost the same. VP can be equal to VN. What do we mean by saturation? It means that VO, output voltage, is always kept between the two power supply voltages, VCC plus and VCC minus. Okay, so in many cases, for example, if you use op-amp with no feedback, or if you use it with positive feedback, we'll get to a situation that op-amp gets saturated. It means that VO either becomes VCC plus if it's very large, or becomes VCC minus if it's very small. Okay, in that case, this is not true anymore. So VP and VN are gonna be different because op-amp cannot keep these two voltages the same when we are in the saturation. When do we have saturation? When we use op-amp in the open loop case like this. You saw this in ELEX 3130 that if you use op-amp as an open loop op-amp, as an open loop circuit, this circuit is basically used as a comparator. Output, it's either gonna be VCC plus or VCC minus. If VP is bigger than VN, output it's gonna be VCC plus. If VP is smaller than VN, output it's gonna be VCC minus. If you have negative feedback, on the other hand, it's the same concept that we have in control. Once you have negative feedback, then basically op-amp can keep track of the difference between these two and tries to minimize their difference, the delta V, which is the difference between VP and VN. So in the circuits that I'm gonna show you, we're gonna have negative feedback. So we have both of these cases. We have both of these rules that the input current it's gonna be 0 and VP is equal to VN. The non-inverting voltage is the same as inverting voltage. So this is just a review for op-amps. Now let's see some of the circuits that you already saw in your previous course or like previous courses. Let's first start with amplifier. Okay, so this circuit, negative, positive, and VO, and we have a negative feedback here. Let's have our input voltage here and let's ground this one. Okay, let me call this one R1 and this one R2. Okay, if that's the case, so here we have negative feedback. So op-amp, if Vin is not very big and if you choose R1 and R2 carefully, output voltage is smaller than these, it's between these two supply voltages. So we can assume that these two voltages are the same. We can also assume that these currents are 0. So if this voltage, the non-inverting voltage, is the same as this voltage, the inverting voltage, then we can assume that this voltage is 0, right? Because this one is grounded, this one becomes 0. We call this virtual ground. It's not connected to ground physically, but op-amp makes sure that these two voltages are the same, so the potential for